For any framed structure, the total load on slab is given by live load, floor finishes, and the self-weight of the slab. This load is transferred to the beams which provide support to the slab, and from the beams, the load is transferred to the supporting columns. The load from the column is then transferred to the footing. Finally, the load is transferred to the soil, on which the whole structure is built. In this webinar, I am going to show you how to calculate the load in slabs and beams. For example, the slab of the figure shown below has a thickness of 150 mm and in addition to its own weight, it supports 0.85 kN per square meters partition, and a live load of 2.4 kN per square meters. Transfer the load of the slab to the beams on all four sides. Loads on a two-way slab are transferred to all beams on all the sides. So, each beam supports an amount of the load from the slab. The slab is commonly divided into trapezoidal and triangular areas by drawing lines from each corner of the rectangle at 45 degrees. The load of the one-way slab, which has a rectangular shape, is divided equally between adjacent beams. The interior beam takes half of the total load of a slab on each side. If a slab is supported on two sides only or supported on all four sides, but the longer side to shorter side ratio is greater than 2, it is termed as one-way slab, see figure. The beam's distributed load is computed by multiplying the segment area, trapezoidal or triangular area, by the slab's unit load divided by the beam length. For an interior beam, the portion of the other side slab weight is estimated in a similar way and added to the previous one, i.e., the slab's load from the other side of the beam. So, interior beams take loads from both the sides. Self-weight of the slab equals slab thickness multiplied by concrete unit weight. Equals 0.15 times 24 equals 3.6 kN per square meters. The characteristic dead load, 4.13.6 plus 0.85 equals 4.45 kN per square meters. The characteristic imposed load, 2.4 kN per square meters. One can distribute service load, unfactored load, to the beam or ultimate distributed load to the slab, use factored load for both dead load and live load of the slab according to the specifications of ACI 318-19. In this example, we use different load factors and then use load combination to calculate ultimate distributed load on the slab. After that, the ultimate distributed load is transferred to the beams. Ultimate distributed load equals 1.2 times dead load plus 1.6 times live load. Ultimate distributed load equals 1.2 times 4.45 plus 1.4 times 2.4 equals 8.7 kN per square meters. Load of slab on beam, 4m, equals area of triangle times W. Equals 4 times 8.7 equals 34.8 kN. Uniform distributed load of slab on beam, 4m, equals 34.8/4 equals 8.7 kN/m. Load of slab on beam, 4m, equals area of trapezoidal *W. Equals 8 times 8.7 equals 69.6 knots. Uniform distributed load of slab on beam, 6m, equals 69.6/6 equals 11.6 kN/m. The beams are supporting a suspended partition wall of consisting of bricks with an unit weight of 18 knots per cubic meter, and height of 4m, the beam of size is 500 by 200 mm. Calculate total uniform distributed load acting on beam considering dead load from 150 thick slab on beam, 4m equals 8.7 kN per square meters. Self-weight of the beam equals depth of beam, 0.5, minus depth of slab, 0.15, times thickness of beam times 24 equals 1.68 kN/m. Weight of masonry wall equals wall height times wall thickness times masonry brick unit weight equals 4 times 0.2 times 18 equals 14.4 kN/m. Characteristic dead load on the beam 24.78 kN per meters. Characteristic imposed load on the beam, 4.0 times 2.4 equals 9.6 kN per meters. Maximum design load on the beam, 1.4 times 24.78 plus 1.6 times 9.6 equals 50.052 kN per meters.